Good morning, everyone, and welcome back sa subject natin, design of steel structures. So for this session, we will just continue yung um, last two examples natin or yung continuation ng last example natin for item B and C in solving for the design strength of the given section natin. So analysis lang muna tayo. No? So we are just determining the value of the ultimate moment capacity of the given section given yung loadings natin. Right? So as a recall dun sa na-discuss nating analysis procedure before, we have here, I tabulated yung steps or I enumerated rather yung steps na gagamitin natin. First is to identify all necessary material properties of the given section. This means we need to write first all the required properties such as the area, the inertia, the section modulus, the radius of gyration. So whatever property needed in the calculation of the succeeding steps should be first identified, or you can always go back dun sa um, mismong Excel file natin of properties to get yung values natin. And then right after getting all of those values, we need to check for compactness. So how do we check for compactness? We have the formula for the ratio uh, of the width over thickness. And for I section, which is sabi natin last time, si I section yung most economical section for now na ginagamit in practice. Kaya yung ginamit nating formula are for I section, and then we determine yung width over thickness ratio, yung lambda natin in terms ni flange, and then lambda natin in terms ni web. And then kinumpare natin siya sa lambda P and lambda R, which are the requirement o yung mga zone natin, yung mga section natin to indicate na kapag yung lambda natin is less than LP or less than lambda P, that means we have a compact section. And then if it's in between ng lambda P and lambda R, it is a non-compact section. And then kapag greater than lambda R siya, it will be a slender section na meron siyang different formula according to sa NSCP natin as we have discussed previously. Okay. Then after identifying the formula required for compactness or how we um, analyze yung section natin, we need to solve for the nominal moment. And in solving for the nominal moment of the section, we have two limit states. Wherein dapat, pag chinek natin yung limit states na to, whichever is lesser dun sa dalawa, that will be the governing value of our nominal moment. And we check it first by yielding, by getting the plastic moment capacity of the section, wherein we utilize yung Fy niya multiplied by the plastic modulus Zx. Okay? And then the other limit state is yung tinatawag natin lateral torsional buckling. And we have already stated na si lateral torsional buckling deals with the stability of our section to yielding to to deflection or to torsional effects. And makikita natin dito on the figure on the right side from ASCE library the difference of two installation na ginagawa natin in this. I think this is from a bridge na meron tayong cross frames and lateral bracing. Si cross frames, ito yung diaphragm sinasabi natin. Si cross frames lang is nodal yung kanyang pag reduce nung kanyang twisting effect, no? Kasi pwede mag-twist yung member natin. And then dito sa lateral buckling natin, si lateral bracing, nilalagay natin usually sa flanges nung section natin. And as you can see on this picture, it's connected dun sa bottom flange natin to control any buckling on that area. Kasi yung sa top, since may slab yun, so parang fully brace na siya dun sa area na yun kasi may slab na na pwedeng mag-resist nung ating forces sideways or yung lateral force natin on the side. Kaya wala na siyempre doon sa taas. Kaya doon sa bottom na lang siya naglagay as reinforcement sa lateral forces natin doon sa flanges natin. Okay? And then meron tayong tatlong conditions for lateral torsional backling. This is also used to calculate kung ano yung magiging formula natin in getting for the nominal moment. And then kapag yung unbraced length natin sa dub as LB is less than sa LP, later papakita natin yung formula of LP. Ibig sabihin niya no instability or fully supported yung ating beam. Okay, so meaning, yung ating nominal moment ay equal lang dun sa moment plastic natin, o yung plastic moment capacity ng beam natin. And then kapag in between siya ng LP and LR, it is said as inelastic lateral torsional buckling. And then we have also a formula for that. And then LB in greater than LR, that is the nating elastic lateral torsional buckling. And as you can see here, there is a note na equations for these parameters are based on the theory of elastic stability discussed by Timoshenko and Gear dun sa libro na lang Theory of Elastic Stability in 1961. And these equations are presented in NSCP section 506 2.2 page 5-64. So let me share yung NSCP natin to check kung nasan yon. So ito yung NSCP natin, and then as you can see, sabi sa 506.2.2, ayan, lateral torsional backling, page 5-64, we can see na ito yung first condition natin when LB is less than LP. Ito yung limit state natin does not, yung LTB natin does not apply. So we will use, or ang governing natin is yielding lang kasi does not apply ito or wala tayong LTB. Then kapag within or nasa in-between siya ng LP and LR, ito yung gagamitin natin formula sa kanya. Na later, mayroon tayong example how to use this formula. And then, pag LB is greater than LR, we have also this formula. Okay? Na ito yung mga formulas on those sa mga respective na values natin. And then for LP and LR, ito yung formula natin sa kanya. Na later, i-discuss natin isa-isa para mas maintindihan natin masyado kung paano ginagamit yung formula natin. As you can see, very long yung formula natin for LR na I will show you a trick how to calculate this one in a much more convenient manner. Okay? So going back with our slide. So after identifying what is our nominal capacity, the next thing to do is to determine yung ating design strength. Depende sa problem if it's requiring ultimate moment. So we just need to multiply our MN by phi or yung 0.9 natin para sa flexure. And then kung allowable tayo, we just need to divide it by our safety factor na 1.67 to get the allowable moment capacity. Depende kung LRFD o ASD yung pinapakuha sa atin. Right? So let's go back to sa example natin. So ito yung previous example natin na yung first one, yung conditions with continuous lateral buckling. So kapag continuous yung lateral backling natin, ibig sabihin, yung LTB natin dito is neglected na, no? Okay? So ibig sabihin dito sa step natin, dito sa limit state natin, itong RB is wala na agad. Kaya ang yielding natin is based dun sa value ng, yung nominal moment natin is based na lang sa value ni plastic moment. Kaya dito sa value natin, na-calculate natin yung MP. Pero I just noticed na dapat design flexural strength yung hanap natin, no? So, siguro to end this letter A, we need to multiply yung MP natin. Di ba magiging MN is equals to MP na tayo. Pero since ultimate or design strength yung ginagamit, gawin na natin LRFD, kailangan natin ng VMN or VMP. So we just need to multiply that by 0.9, then 376.05 kilonewton meter. So yung pinaka-answer talaga dito for this problem is actually MU equals to 376.65 times 0.9, that is 338.445 kilonewton meter. So this will be our final answer. Okay? So, recap lang natin yung ginawa natin. Yung first step natin, we enumerated or we tabulated or we write all of the required na properties natin. Then number two, check for compactness. As you can see here, yung gamma P and gamma R natin are calculated dun sa previous example pa natin before. And then, ito yung actual na gamma nung section natin. So, kinuha lang natin. And then, as you can see, compact yung section natin for flange and web. Okay? Then, after getting na compact na yung section natin, we calculate na yung ating nominal capacity wherein MP is equals to MN. Then, ito na nga. Babalik na tayo dito. Wherein yung design moment natin. So, this is our step 3. And ito yung step 4 natin. Okay? Ayan. So, basta clear tayo dito. So, what we need to do now is to continue our example with letter B. Wherein, unbraced length is equals to 3,000 mm, MCB is equals to 1.0. So, ayan. So, okay na tayo dun sa first example. So, sa LB naman tayo. So, ang kailangan natin is unbraced length of 3,000 and CB is equals to 1.0. So, let's calculate. So, we have here yung LB daw natin is equals to 3,000 mm. Okay? Then CB is equals to 1.0. So, kailangan natin makuha kung nasaan zone si LB ngayon. No? So, to do that is to calculate yung LP and LR natin. Pero kailangan ipakita natin siya sa graph, parang graph. No? So, let's say ito yung value ng LB, represent itong somewhere dito sa line na to. And then, ito yung para sa LP, and ito yung para sa LR. Okay? So, tawagan na lang natin ng mga zones to. Case 1, case 2, case 3 natin. So, tawagin natin itong zone 1. Lagay natin sa ilalim. Okay. Si zone 1, ang sabi natin kanina doon sa first slide natin dito, pag si zone 1, pag nag-less than si LB doon, no instability siya. Pag in between inelastic and then elastic LTB yung last case natin. So, lagay natin doon. Okay. So, yung zone 1 natin is yung mga ulit. No instability. Okay? No instability yung lalagay natin. So, ito yung area na no instability. Okay? Okay, zone 2 is yung ating inelastic LTV. Okay, zone 3 is yung ating elastic LTV. Okay? So now we need to calculate for LP. And according to sa formula sa NSCP, let me write lang yung ating formulas. Ito yung LP natin. So LP is equals to 1.76 RY square root of E over FY. Okay? And we have the formula for LR is equals to 1.95 RTS E over 0.7 of Fy, then square root of J times C all over SXHO, square root of 1 plus square root of 1 plus 6.76 multiplied by 0.7 Fy E times SXHO all over JC squared. Okay, so that will be our formula for LR. Then we have the formula for RTS squared. I'm just copying muna, no? That is square root of IY CW all over SX. Okay? Then we have to note here kasi gagamitin natin si C later on dito no, sa formula na for doubly asymmetric I shape, C is equals to 1. So note natin na C is equals to 1. And then nakalagay dito yung H sub O is the distance between flange centroid. So later pakita na lang natin kung paano calculate yan. Okay? So going back to sa slide natin. Okay. So, ito yung formula natin for LP as copy dun sa NSCP natin, and then for LR is ito. Okay? So, sa LP muna tayo. Kailangan natin ay si RY and si E and FY. Si E and FY, no problem kasi we identified that on the previous slide. Pero si RY, hindi pa natin na-identify. So, we need to get our AIC ano no? AISC table. Okay. So, as you can see here, na-filter ko na yan from our previous example. 18 by 35. So, kailangan natin yung RY. So, RY is ito, 31 mm. Okay? So, substitute na natin yan sa formula. Kunin na din natin yung ibang kailangan para dun sa LR naman. Okay? So, we need also a value of IY. Sige, later na lang para di tayo palito. So, going back muna. So, RY natin is equals to 31 tayo. Okay? So, RY is 31. So, we have 1.76 times 31 divided by 200 times 10 to the 3 all over 345. So, yung LP natin is equals to, calculate nyo lang, 1.76 times 31, square root of 200,000 divided by 345. That is 1313.65. Okay, mm. Ibig sabihin yung LP natin is 1313.65. Okay? Next, LR tayo. So, pag gamit kay LR, ito yung formula kailangan natin, pero kailangan natin si RTS. Ito yung formula ni RTS. Kailangan natin ng value ng inertia, and for the warping constant na meron sa NSCP, and for SX, kailangan din natin. Then, ano pong kailangan natin? Yung H sub O, no? Yung H sub O natin, makukuha yan. So, if ever we have here our, ito yung I section natin. Sabi center to center distance. So, ito yung center nung flange natin. So, yan yung value ng ating H sub O. Or equal sa depth natin minus yung thickness ng flange natin. Okay? So, kunin natin yung mga required na properties for this formula. So, let's go back dito sa ating Excel. Okay? So, what we need is yung value for IY muna, no? So, IY, kailangan natin si IY. IY is 6.37. Pero anong unit? Tingnan nyo dito sa readme na tab. Yung IY, yan nakalagay dito. Ang unit niya is mm/4. Tapos, kailangan mo siyang multiply ng times 10 to the 6. Times 10 to the 6 mm to the 4. Okay? Next, kailangan natin yung CW. CW is ito. Okay? CW is equals to 306. Ang unit niya is dito, CW, warping constant, mm to the 6, at times 10 to the 9. No? Mm to the 6. So, ibig sabihin nung nakalagay dito, yung value nasa table is divided by 10 to the 9. Kaya yung actual value niya, dapat i-multiply mo ng 10 raised to 9. Tapos, ang unit niya is mm to the 6. Okay? So, yan yung ibig sabihin niya. Okay, next. After ng CW, we need yung value ng depth. Okay? Para dun sa H sub O natin. So, ang value ng depth natin is... Sorry. Yung value ng depth natin. Scroll lang natin a little further. 40. Ayan. Yung D natin is 450. Siyempre, mm yan. Kasi depth yan ng ating section. Then, ang thickness ng flange natin, although na-identify na natin last time to, i-phone ko na lang. 10.8 mm. Okay, and then we need a value for SX, no? Yung section modulus natin. So, SX, SX. Ayan, ito. So, 944. 944. Then, ang unit niyan, balik ka dito. SX is equals to times 10 to the 3 mm cube. Okay? Then, last is yung ating value of J. Okay? Yung ating polar moment of inertia. Nandito din yan. Somewhere dito natin. Ayan. Ito. 211. Unit niya. Punta ka dito. 211. Yan. Times 10 to the 3. mm cube. Okay? So I think yun lang yung mga kailangan natin from this table. So let's go back dun sa ating slide. Kasi I have already written yung mga kailangan natin values sa table and presented na dun sa PowerPoint natin. Ayan. Okay? So ito yung lahat ng nanggaling dun sa table na yan. No? Nire-write ko lang. Okay? So we need to indicate yung values. So dito, calculate muna natin si RTS. No? So equals, IY natin is 6.37 times 10 to the 6 times CW na 306 times 10 to the 9 square root over yung value ng SX natin na 944 times 10 cube. Okay? So, pag nakuha natin yung value nito, i-square root lang natin both side para makuha natin yung RTS lang. Okay? So, 6.30 square root of 6.37 times 10 to the 6 times 306 times 10 to the 9 all over 944 times 10 to the 3. Okay, then square root of that answer. We have 38.457, okay, as our value. And this is, since this is R, mm to. Okay, so yung technique dito sa formulang to, before I forget, is to store yung values natin sa calculus. So, paano natin gagawin yan? So, ibaba lang natin ng konti itong formula natin dito. So, yeah, transfer lang natin ng konti. Okay? So, makita nyo dito, si RTS, ito yan, no? So, yung makukuha mo value for RTS, multiply mo na agad ng 1.95. Okay? So, pag minultiply mo ng 1.95, ito, i-store mo sa letter A ng calculus mo. Okay? And then, ito, mapapansin nyo, E over 0.7 FY. Ito is the same nitong nandito. Reciprocal lang siya. Okay? So, ibig sabihin, kunin mo siya separately, yung value nito muna. Okay? Then, itong portion na to, i-store mo sa letter B. Then, pag in-input mo siya dito sa part na to, that will be 1 over B. Okay? Next is ito, yung JC, yung nasa loob ng square root. Itong value na to, same lang din siya nitong value na to. Naka-reciprocal lang ulit. Okay? So, what you will do is to, again, use this value or get this value. And then dito, pag i-calculate mo na siya, you just need to substitute 1 over C. Okay? So, mangyayari doon sa formula natin ngayon, it will be much simpler na, no? to input, hindi ka na magkakamali or less na yung mistake, no? Yung probability na magka-mistake ka. Kasi ang i-input mo na lang sa LR will be A, B, square root of C, square root of 1 plus 6.76 times 1 over B times 1 over C squared. Yeah. So, ganyan na lang yung formula mo. Okay? So, let's do that. So, yung sa letter A natin, okay, for letter A, 1.95 times yung RTS natin at 38,457. Okay, times 1.95, yung previous calculation na lang, that is 74.99992. Okay, tapos store nyo na lang sa calcu. Discover or um, i-try yung ano sa calcu kung paano siya nakukuha. So, halimbawa, kung tayo, meron na yung calcu din, no? Ano po ang papakita ito? Okay, so, siguro, ayan. So, while naka-open tayo, okay, ito. So, sa calcu natin, ito. So, halimbawa, meron tayong na-calculate na values, diba? 38.457 yung ating R. Okay? Sa-times natin ng 1.95. Ito yung para sa letter A natin. Okay? Equals, ito yung value. Kailangan shift, tapos store, tapos pipili ka lang ng letter dito. Lagay natin A. Okay? So, ibig sabihin, kapag nag-alpha A ka, laging lalabas na yung value na yun. Okay? So, ganoon din yung gagawin natin dun sa other values natin na gamit natin dun sa formula natin. Okay? So, for B, let me use lang the same color. So, for B, okay? So, yung B natin is E over 0.7 ng Fy. So, ang E natin is 200 times 10 to the 3 all over 0.7 ng 345. Whatever yung answer niya, store natin sa B. Okay? So, 200 times 10 to the 3 all over 0.7 times 345. Then, store na lang natin. Store na lang sa B. Okay? Next, letter C. C natin is J times C all over SXHO. So, ang J natin is 211 times 10 to the 3. Times C natin, according dun sa NSCP natin, 1.0 for I shape. All over. SX natin, 944 times 10 to the 3. And then, ang H sub O natin, again, is D minus DF. No? So, D natin is 450 minus 10.8. Okay? Whatever the answer, store natin sa letter C. Okay? So, let me calculate lang sa calcul ko. 211 times 10 to the 3 times 1.0 over 944 times 10 to the 3 times 450 minus 10.8. Then, store nyo sa letter C. Okay? So, pakita natin sa calcul. Okay? Meron na tayo ng letter A. Ngayon, si letter B. So, pakita natin 200 times 10 to the 3 all over yung 0.75 ng 345. Ayan. So, ito yung value ng B natin. So, shift, itong RCL, tapos letter B. So, ayan na yung value ng letter B. Then, for letter C, kailangan natin is JC. So, 211 times 10 to the 3 times 1. Okay. All over 944 times 10 to the 3 times yung value natin na 450 minus 10. Okay. Ito yung value natin. Shift store lang natin sa value ng C. Okay. So, ayan. Naroon tayo ng value ng ABC. So, compute for LR. LR natin will be A times B tapos times square root ng C times square root of, we have 1 plus 6.76 multiplied by 1 over alpha b times 1 over alpha c. Okay, and then we need to square this quantity and then equals. Okay, so let me check kung saan tayo may kulang na value or maling quantity. Square root, kulang pala tayo, no? So dito, bago tayo mag-square root nito, dapat meron pa tayong square root. I think we need to rearrange those. So A, B, then square root of C, then multiplied by square root of 1 plus square root of 1 plus 6.76. Okay? Then quantity 1 over, pwede nyo pagsamahin actually itong B at C dito, no? Kasi multiply naman yan. Squared. Okay? Then tsaka natin equate. Ayan. So yung makukuha nating value for our formula is, or LR natin is 3624.939. Okay? So, let me again clarify kung tama, no? So, we have A times B, the square root of C, times 1 plus 6.76, 1 over B and C, and square natin. Okay, so, bakit iba yung value ko, no? Let me check ulit. 6.76. So, check natin tong value ng A. Okay. Ayan. So, may konting discrepancy kapag iba yung calc yung gamit niya, no? Yung gamit yung calcu kasi is 350EX. Yung value ng A ko is different. Or kapag nag-round off tayo, will be different. Kasi dapat yung RTS natin, kanina, doon sa formula natin, let me share yung slide natin. Okay. So dito, yung kinumpute natin yung RTS kanina, ito is rounded value to, no? So kung gusto natin mas exact yung value natin, ito kasing value na to, galing to do sa exact na formula, na equation, no? Na 38.457 blah 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 dito, no? Tapos mo-multiply natin ng 1.95 tsaka natin i-store dito. Okay? So mula dun sa nakalagay natin, para makita nyo lang, dito. So, recalculate ko lang yung ating RTS. So, that is the square root of 6.37 times 10 to the 6 times yung ating 306 times 10 to the 9 all over yung 944 times 10 to the 3. So, ito yung value niya. Then, square root natin yan. Yan, ito dapat yung value natin. Yung nakalagay natin sa PowerPoint is hanggang 7 lang. So, try natin ito yung i-multiply natin ng 1.95. 95. Okay? Yan. So, ito dapat yung exact value natin. Ito yung store natin doon sa letter A natin. Okay? Then, when we try to calculate again yung ating LR, okay, then square root of 1 plus square root of 1 plus 6.76 multiplied by 1 over B and C. And dapat naka-square dito. So, yung exact value ng LR natin should be this one, no? 3624.939. 0.97. Oh, same naman pala. Halos, no? So, yeah. Um, 1 plus 6.76 times 1 over DC. So, I think may other value, no? Doon kasi sa handheld calculator na gamit ko, iba yung value lumalabas, no? So, maybe sa value ng B at C, may konting difference. Yung sa B natin, let's try to recalculate yung B. We have 200 times 10 to the 3 all over 0.7 times 345. Okay? So, this should be 828. So, try natin lagay sa B ulit. Okay? Then, i-recalculate natin to. Ayan. So, yung B, yung mali pala ang calculation ko kanina. Okay? So, yan. So, ito dapat 3772. So, 3772.285 mm. Going back to sa ating slide. Ayan. So, itong formula na to, padagdag na lang ako nitong ano, kasi hindi na kasya or ano yun ko na. Baka may mag-comment kasi. Okay. So, dapat ito is merong square root of 1 plus. Ayan. Okay, so upon calculating, ito yung nakuha natin, 3772. Kung makikita natin dito, lalagay natin 3772.285. So, ibig sabihin, yung value natin na 3,000 is in between itong 11313 tsaka 3772. So, somewhere siya dito, no? Yan, sabihin natin nandito siya. So, ibig sabihin, yung LB natin is LP is less than LR or less than or equal to LR. LR. So, meaning tayo ay zone 2. Okay? So, pag zone 2 tayo, meron tayong inelastic LTB, no? Lateral torsional buckling. Okay? So, pag yan yung case, balik tayo doon sa NCP natin. Ayan. So, zone 2 tayo. So, ang formula natin for moment capacity is this one. Okay? Nominal capacity. So, let me write lang yung equation dun sa slide natin before I head back. Mn is equals to Cb multiplied by Mp minus Mp minus 0.7 of Fy Sx multiplied by Lb minus Lp all over Lr minus Lp. So, kailangan meron tayo ng value ng ating ano, no? LP and LR. So, let me write din yung values na na-calculate natin. So, okay. So, once we get itong formula na to, let's go back to sa slide. Ayan, so ito yung slide na yon. So, substitute na lang natin yung values niyan dito. Okay? Yung SX natin is galing dito sa kabila. 944 times 10 to the 3 siya, no? So, SX natin, 944 times 10 to the 3. Okay? Then yung MP natin is calculated dun sa previous example natin, no? Ito, 376.05. So, ito is 376.05 kilonewton meter. So, para maging Newton mm, 376.05 times 10 to the 6 Newton mm. Kasi kailangan uniform yung ating units. Okay, so dito CB natin is 1.0 as indicated sa problem. We have 376.05 times 10 to the 6 minus yung MP natin 376.05 times 10 to the 6 minus 0.7 ng FY 345. Then SX natin is 944 times 10 cubed multiplied by So LB natin, ito, 3772.285 minus 1313.65 all over 1 over 3772.285 minus um, mali yung first ko dito, no? So this should be LB. So 3,000. Okay? Then this is LP 1313.65. Okay? Then, so calculate lang natin. Then convert to kilonewton meter. Kung ano yung makukuha natin. So we have 376 times 0.05 times 10 to the 6 minus 376.05 times 10 to the 6 minus 0.7345. Then 944 times 10 to the 3 multiplied by 3,000 minus 1313.65 and then 3772.285 minus 1313.65. So, kunin natin yung values nito. So, dapat mindful tayo sa quantity, no? Dito sa ginawa ko, hindi ko nalagyan ng quantity dito, no? So, meron dapat tong quantity. So, dapat to may quantity siya dito. Okay? Para hindi kulang yung ating. Ayan. And then, divide natin sa 1 million o makukuha natin yung 274.488 kilonewton meter. Okay? So, ito yung nominal capacity natin which is less than dun sa MP natin na 376.05. So, according dun sa step 3 natin, whichever is lesser, yun yung magiging capacity natin. Therefore, MN natin dito is equals to 274.488 kilonewton meter. Okay? And para makuha yung ultimate capacity natin, that will be VMN. So, 0.9 times yung 274.488 kilonewton meter. So, yung ating MU o yung design strength natin for LRFD ng case 2 o letter B natin will be equal sa 247.039 kilonewton meter. Okay? So, applying yung lahat ng equations natin, this is our answer. Okay? So, ayan yung para sa letter B natin. Okay? Ayan. So, okay na tayo sa letter B. Okay? Next is to calculate yung letter C natin. So, let me duplicate lang tong ating problem. So, we have here bali ito. Then ito. Okay, so for letter C naman tayo. So letter C tayo, meron daw tayong LB is equals to 6,000 mm. CB is equals to 1.0. Okay, so now meron tayong na-calculate na before, di ba? I-copy na lang natin ito, no? Na nakita naman natin na ito yung ating range. Yan, ito yung range natin na kailangan. So, lagyan natin dito kung saan magpo-fall under yung ating case letter C, no? Okay, so ito yung na-calculate natin sa previous, no? So, we don't need to repeat everything. So, si 6,000 mm tayo. So, ito yung limit natin for LR. So, si 6,000 definitely will fall under somewhere dito, no? Or beyond, no? So, ibig sabihin tayo ay zone 3 or elastic LTB. Kasi nga, yung ating LB is greater than sa LR natin. Okay? And Looking at the code, and kapag LB is greater than LR natin, ito yung formula natin for MN. So, MN is equals to FCR times SX natin. And si FCR, may formula siya. Ito yung formula niya. No? I-write natin, we have CB pi squared E all over LB over RTS, then square root of 1 plus 0.078 JC all over SXHO, and then LB RTS squared. Okay? So, ayan. So, lahat naman nung ano yan, I think na-calculate na natin kanina. We just need to substitute yung values natin dun sa formula natin. Okay? So, if you want to lessen all again yung ano natin, formulation, we can, since ito is also present dito, no? We can store again another letter, no? We can use halimbawa yung letter D since hindi pa natin nagagamit. Gawin natin tong letter D. So this will be letter D also. And as you can see, itong JC over SXHO, ano yan? Dito, ito yan, no? Yung letter C natin kanina. Okay? So dito, sa formula natin sa case number 3, ito yung C natin. Okay? So what we can do now sa FCR natin na formula will be CB pi squared E all over D square root of 1 plus 0.078 times C times D. Yan na lang yung formula natin. Okay? So, kunin natin ngayon yung value ng D natin. So, ganun na lang din, no? So, let's go ahead dito. D natin is equals to LB all over RTS squared. So, LB natin ngayon is 6,000. Okay, all over. Yung RTS natin, na-calculate natin is 38.457. Then, i-squared natin yon. Then, i-store natin sa letter D. So, this should be violet ang color nito, no? Yeah. So, you have 6,000 all over 38.457. Then, squared. We have okay. So, kung sa calci natin, ito, yung calci natin, we have 6,000, quantity 6,000 all over 38.457 squared equals, and then shift, store, letter D tayo. Okay? Then to calculate for FCR, substitute lang natin yung values. And we have CB. CB natin is 1.0. Okay? Then pi natin, so times pi squared. Okay? Then E is 200,000 all over yung ating value ng D. Okay? Then multiplied by square root ni 1 plus 0.078, then times C times D. Okay? So, ayan. So, ano yung makukuha nating value? That is 113.71. So, let me write that value. 113.71 MPa. Okay? So, going back do sa PowerPoint. So, for a while lang, medyo na ano lang na lalag lang yung ating PowerPoint. Okay, so yung nilagay natin sa calculator, kung galing yun dito, no? CB pi squared E over D, tapos square root of 1.078 CD. No? So kung ano man yung value natin dyan, so yan yung ginawa natin formula sa kanya. Okay? So yan, since meron tayong value ng FCR, we can use na this equation to calculate for MN. So MN natin will be equals to FCR 113.71 Newton per mm squared. Then, ang value ng SX natin, if you check dito sa previous natin, SX natin is 944 times 10 to the 3. So, 944 times 10 to the 3, that is mm cube. No? Pag minultiply natin, 113.71 times 944 times 10 to the 3, then divide natin by 1 million. We have 107.342 kilonewton meter as our MN, which is less than doon sa ating value ng MP. Okay? Therefore, okay, ang ating MU or ang ating VMN for case number 3 or letter C will be equals to 0.9 times 107,342 kilonewton meter. So that will be 96.608 kilonewton meter para dun sa ating MU. So LRFD lang yung chinek natin, pero if you want to check, you can just divide sa safety factor para makuha natin yung allowable moment, okay, for ASD. Okay? So ito yung para sa letter C natin. So ganyan po kinakalculate yung values niyan according dun sa formula or dun sa conditions presented dun sa NSCP natin. Depende kung saan magpo-fall under yung value ng LB natin. Kung less than LP, in between LP and LR, or greater than LR. Okay? So, anong observation yung kailangan natin tandaan dito sa problem natin to? So, we can look at this table, no? So, nung no instability tayo or nung nandun tayo sa zone 1, okay? Nakita natin na yung value ng ating nominal moment is the same as nung ating plastic moment. Meaning, wala tayong stability or fully laterally restrained yung ating member. So, ay makita natin maximize yung capacity ng mismong beam natin. And as we have lateral torsional buckling along dun sa length natin or kapag pumasok na tayo sa zone 2, no? Makikita natin nagkameron ng linear decrease dun sa ating section, no? Hanggang dito sa LR, sa value ng LR. Na mapapansin natin from our example, yung MP natin, no, is equal sa how much yung MP natin. So yung MP natin from previous example is 376.05. So ito yung capacity niya nung fully restrained siya. Ngayon, nung pumasok siya sa zone 2, yung naging capacity natin ng MN ay 247.04 kilonewton meter. Kasi nga, nandito na somewhere yung lateral, yung LB natin, yung unbraced length natin. So, ibig sabihin, nag-decrease na, no? And then, nung pumasok tayo sa zone 3, makikita nyo, kahit gaano kabigat o kaganda yung section natin, pag hindi siya laterally restrained, yung capacity natin is lumiliit masyado yung value niya. Okay? So, what does this table indicate? This table indicate na yung ating capacity o yung moment strength capacity natin is dependent dun sa lateral torsional buckling natin or yung moment strength ng compact shape natin is a function ng unbraced length natin. Okay? And si unbraced length again is yung definition natin dun kung saan tayo may lateral support. So kung pertaining tayo dito sa figure na to, kung saan tayo may support, so dito, yung distance na ito hanggang dito sa to, kung saan tayo may lateral support. Ito yung value ng ating LB kung figure lang yung binigay sa atin. Okay? For support to support um, na na lateral bracing. Okay? So mahalagang tandaan to na if you want your section to have its full capacity, mas maganda is i-laterally restrain natin siya all throughout. Pero depende sa application niya. Meron kasi na hindi na siya economical, no? Pag nilagyan mo pa ng bracing all throughout ng length niya, so you need to check kung saan magfo-fall under yung capacity, yung kung anong zone magfo-fall under yung mismong section ninyo, and then you can decide kung how much yung nominal capacity na kayang i-carry ng section niyo. Okay? So that is about yung moment strength natin. Okay? So that ends our lecture for today regarding the moment strength of a lateral of our beam. Okay? Next session will be the discussion of our shear strength and then deflection limits and also other consideration kapag nagsosolve tayo ng beams. Okay? So see you guys again next time.